All right, 8th graders, I hope you really are watching this because you promised me you would. All right, so on this example, this is the one we got to. So basically, these exponents, even this invisible 1 that we can't see, is being raised to the 3rd power. So 1 times 3 is 3. And then 8 times 3 is 24. But we do need to simplify 4 to the 3rd power. So use your calculator, type in 4, type in your caret button, type in 3, and then hit enter. I'm going to do it too. So 4 to the 3rd power is 64. So to simplify this, our final answer is 64x to the 24th. Now we're done. All right, here we're going to multiply that invisible 1 by 2. So 1 times 2 is 2. And then 6 times 2 is 12. Well, what is 3 squared? 3 times 3 is 9. All right, moving on. These are the try-its. So I want you guys to do both of these. There's only 2 of them. Pause the video and then come back and check your answer. All right, so we have 7 to the 4th times x to the 36th. And then what is 7 to the 4th? It is 2,401 x to the 36th. And here we have 3 to the 7th, x to the 7th, y to the 70th. We're multiplying, right? And then 3 raised to the 7th is 2,187. X7, Y70. And that is the answer. Hopefully you got those. All right, now, so when you have a negative number, so obviously if you have a negative times a negative, you get a positive, right? So if you have a negative 4 squared, you're going to end up getting a positive 16 because it's negative 4 times negative 4. However, if you have negative 4 to the 3rd power, you're going to end up with a negative answer because negative 4 times negative 4 is positive 16, but then positive 16 times negative 4 is negative 64. So the rule is if your exponent that you are raising your negative number to is even, your answer is positive. Even means positive. If that exponent that you're raising that negative to is odd, like 3 is odd, you're going to end up with a negative coefficient in the front. So here we have negative 3 squared. It's negative 3. If you type this in your calculator, you must use the parentheses or your answer will be wrong. If you just type in negative 3 squared in your calculator without parentheses, it will tell you the answer is negative 9, but it isn't. However, in your calculator, type in parentheses, negative 3, end parentheses, and then square it. It will tell you your answer is positive 9, and that is correct. All right, so the question is, do the negatives go or stay? So since this negative is being raised to an even, we're going to end up having a positive 9 as our leading coefficient. And then we would have x to the 4th, y to the 6th. All right, a negative raised to an even is going to be positive. So negative 4 in parentheses raised to the 8th is a great big number, 65,536. And that's positive because this is an even number, times x to the 48th, y to the 8th. Here we have a negative raised to an odd, so we're going to end up having a negative answer. So it's negative 16,807. And then we're going to multiply 6 times 5 and 2 times 5. And on this one, negative 6 raised to the 3rd power. It's going to be negative, my screen's getting awful messy, negative 216x to the 24th y cubed. That is our answer. Hope that makes sense, you guys. All right, what about you guys? Tell me, does the negative go or stay? Here it stays because this is even. Here it, oh no, just kidding. That's wrong. It goes away because that's even. That's the right answer. This one stays because the negative is raised to an odd. Here it stays. Our final answer is going to be a negative coefficient. And this one, it goes away. Goes away because that'd be negative 9 squared is 81 x to the 4th y squared. Okie dokie. All right, now quotient law of exponents. So if you have something that looks like a fraction in parentheses raised to an exponent, you are going to distribute that exponent to everything inside. So here, think about this having an exponent of 1. 1 times n is n, and the y at the bottom is also raised to the n power. So what does it say? Yep, everything gets raised to the 4th power, the numerator and the denominator. Exactly right. So this is an exponent. It kind of looks like a whole number, but it should be an exponent. That's not a great looking example, but anyway, we're multiplying an exponent times exponents on the top and the bottom. So we'd have x to the 36th over y to the 24th. Here we'd have 3 to the 4 times 6 is 24, which would be a huge number, over y to the 30th. Now 3 to the 24th power is really big. What is it? Oh my goodness, I'm not even writing that. That's such a big number. It goes off my calculator screen. But in reality, we would want to simplify that unless the directions say to leave it in exponential form. All right, so if you guys multiply those, pause the video, do it yourself. So we have x to the 33rd over y to the 77th. And here we have 8 to the 20th, which is a huge number, over y to the 40th. Now, when you have a 0 power, anything to the 0 power is 1. Anything to the 0 power is 1. So 0 factors of a base equals 1. Every power has a coefficient of 1. So you can read this if you want to know why would anything be raised to the 0 power be 1? Because in math you have patterns. 5 to the 3rd versus 5 to the 2nd, this should be a 5th of this answer, and it is. Going down 1 exponent, this answer should be a 5th of 25, and it is. Going down 1 exponent, 0 from 1, this should be a 5th. So a 5th of 5 is 1. So that's our pattern. And then finally, we have a negative 1 coefficient. Our next number should be a 5th of 1, and it is. A 5th of 1 is 1/5. All right, so if we multiplied our two coefficients, 9 times 0 is 0, and anything, including a variable, to a 0 power equals 1. All right, we would multiply everything in these parentheses times this exponent. So we'd have 3 to the 0, x to the 0, y to the 0. Well, basically we'd have 1 times 1 times 1. Guess what that equals? 1. That's the answer. All of these equal 1. So this would be 3 to the 0, x to the 0, y to the 0 equals 1 times 1 times 1, which is 1. This, we're multiplying all of our exponents by 0, 0, 0. Guess what that equals? 1. All of them. Even this one. Let me see the bottom one. Did I get a negative 1? I'm going to not put that in parentheses. Negative 5 to the 0 power is, actually this one is negative 1 because that negative 5 was not in parentheses. So that one is negative 1. If you're not sure, like I wasn't 100% sure just then, so I put it in my calculator exactly how it's written, and I know the answer is negative 1. All right, so 7 to the 0 power is 1. X to the 0 power is also 1. Anything except for 0 with an exponent of 0 equals 1. All right, so that was it, guys. I finished. Okay, no, I didn't. I'm just kidding. I have a few more. And we do need to talk about negative exponents. So hang in there, guys. A negative exponent says the number needs to be moved to the opposite location and made positive. If there's a negative exponent in the numerator on the top, it belongs in the denominator. When you flip it over that line, it changes its sign. Okay, if you have a negative exponent in the denominator, to make that negative positive, you would move it up to the numerator. And so there is a little song we like to sing. If you must cross the line, then change the sign. Wow, that was a great song. You know what? I should record that song. I bet it'd be a bestseller, right? If you must cross that line, you better change the sign. I just made that tune up. I'm so creative that way. Look at that. If I was a man, that's what I would look like. All right, so look at this example 1. We have x to the negative second. Now, if I wrote x as a fraction, I would write it x over 1, right? So since x is up in the numerator, I want to get rid of that negative. I'm going to flip it down over the sign, over the line, so I can change the sign. Once I flip it down, that negative goes away. And I can't have nothing left in the numerator. I must put a 1 there. That's just the rules of math, okay? So example 1, that is my answer, simplified without negative exponents. Example 2, my 3 is fine. It doesn't need to move, but that negative 4, in order to make it a positive 4, I got to move it up above the line. When you cross the line, you change the sign. So I'm going to move y up next to x, drop the negative. That's why we're doing this. We want to drop the negative sign. So you got to change positions, okay? So my 2 is just a 2, just like 2 over 1, the number 2. So it stays where it is. That x moves up so we can make it a positive 4. And we don't need to write a denominator of 1. So this is just our final answer because those are all up in the numerator. Now look at the 2. The 2 does not have a negative exponent. The 2 is basically to the first power, and that's positive. So my 2 does not move. Only my x moves down, okay? So we're going to move it across the line. It's going to change the sign. Now, do I move my 5? No, because it's already down in the denominator. It stays down there. So the 2 stays up there, stays up. The y stays on the bottom. That's where it started out as. And the only thing we're moving is the x across the line, and we change the sign. And that is the best answer. Or really, I'd want to, just because of my OCD, I want to center that 2 a little better. And that one just looks better, even though the answers are exactly the same. Hey, let me ask you a question. Evan, what did Jay-Z call his fiance before he got married? Oh, I messed it up. Oh my gosh. I messed it up. I meant to say, what did Jay-Z call his girlfriend before they got married? The answer was fiance. Miss Richardson, that was bad. That was bad. Okay. Hey, try these, everybody. Try these. Only positive exponents. So right now that 3 is up in the numerator. Okay. So if we wrote 3 as a fraction, we'd write 3 over 1. So we're going to flip it over the line and change that negative sign. So it's going to move to the bottom. That 2 becomes positive. You can't have nothing in the numerator, so you must write a 1. And then we can simplify this. 3 squared is 9. So this is equal to 1/9. This is equal to 1/9. All right, 4 over 1. I'm going to flip it over the line, bring it down here. There can be nothing in the numerator. We have to write a 1. And I know that 4 to the 3rd power is 64. So we've simplified it with only positive exponents, or we even went a step further and simplified it all the way. All right, what are we going to move? Only the denominator on this one, right? X to the 3rd stays where it is. We're bringing up x to the 3rd. Well, guess what this is? This is 2 numbers with the same base being multiplied. So what do we do with their exponents? we add them. When you multiply, you add the exponents. And so the final answer is x to the 6th. Okay, we moved this up to make it a positive 3. So it looks like this now. That first one stays where it is. We brought the other one next up to it, the other one up next to it. And now, since we know the rules for when you multiply two numbers with the same base, what do you do with their bases? You add them. Okay. All right, look at number 4. We're going to only move what's down here up. So we leave z to the 6th in the numerator. We bring up next to it z to the 4th. These two numbers have the same base. They're being multiplied. So the directions are, or the rule is to add those exponents. And there we go. All right, you guys try these on your own and then come back to the video and check your answers. All right, so did you guys get 3 to the 2nd power times x to the negative 10th? Because remember, we're multiplying, right? Well, then the directions say only only positive exponents. So this is not a negative exponent. It stays up in the numerator, and 3 squared is 9. But then we got to move x to the negative 10th down in the denominator. So we're dropping it down, and once you go across the line, you get to change the sign. All right, let's look at this one. What can we simplify first? Well, what's c to the 0 power? C to the 0 power is 1, right? And 1 times d to the 18th, it's just d to the 18th. So I'm just getting rid of this. It's just 1, and 1 times anything is the other thing. The other thing we get to simplify, guys, is right here, right? We have d, so we have 13 d's on top. 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 over 18 d's. Oh my goodness. So there's 18 d's, right? So there's even more d's in the bottom. I'm not even counting those. I'm just guessing. 1, 2, 3, 4, 5. So the first 13 pairs would all cancel each other, top and bottom, top and bottom, top and bottom. They all canceled. We still have 5 d's left in the bottom because there were more d's in the bottom than the top. So remember, when you have division of the same base, you subtract those exponents. Well, the difference in 18 and 13 is 5, but where did those 5 d's go? Well, it has to stay in the denominator because there's more d's in the denominator. So the final answer is c to the 19th over, remember, we basically canceled all 13 of those d's. And there's 5 left in the denominator. That is the answer. Okay, that one was confusing, but that's a good example. All right, let's look at number 7. Oh no, my battery. Let me plug it up real quick. Oh my goodness, it's gonna die.